You're on mute, Mr. Buckner.
That makes no sense. Thank you very much.
What happened?
Okay, so I told the story, but I was muted. I've never entered a Zoom where I was muted. Excuse me, and it's probably because of coming in 2 or 3 times, I guess. I don't know. So thank you so much for your patience. I love you all so much for that, but my internet crashed, and I don't think it was just my house. I think it was my neighborhood, because all the troubleshooting I was doing was not resolving the network, the wireless, anything. So yeah, hashtag 2020, gotta laugh at it. Again, thank you for your patience. Let's try a third time with the time remaining. I had this message announced in Canvas on my phone that I was literally about to hit send on, and then I saw the little signal go back up. So yeah, third time's the charm, fingers crossed. It's not the first time I've had network issues at my home, and I'm sure it won't be the last, but let's get it. Okay, so all right, going really quickly. So we know this is the 83, we know this is 25, we know this is the 160, 44, 25. Now, a couple of things that we don't have are, we don't know this distance right here because it's 160 from end to end, but maybe we can figure that out. We also don't know this little distance right here from this notch to the bottom, nor from this notch to the bottom, but it may not be necessary. Now, if we wanted the perimeter, we did a perimeter problem earlier where we added everything up. If this was a perimeter problem, we would need these 2 distances as well. But because it's an area, we can actually kind of circumvent that. So what we want to do, because we know the formula for a rectangle, area is equal to length times width. And if you don't, here's your reminder. This we can kind of mentally divide up into 3 rectangles. We can call this rectangle 1, then we can call this rectangle 2, and then we can call this rectangle 3. So the red, the blue, and the green, we just need to figure out their lengths and widths. The red one is pretty clearly labeled. It's 83 inches this way and 25 inches this way. So let's just call that area 1. So area 1 should be the 83 inches. I'll leave off the units for now, but later in the class we will not, times the 25, and we'll save that for a little bit. Area 2, which is in here. Now, we need to know this distance, but we don't for the moment. We know this is 25, so it's 25 times something. The way we can figure out this distance is, we know all the way across is 160 inches, and we know that this is 25 inches right here. Well, if this is 25 inches, this right here, this top red distance would also be 25 inches. So that's a 25. And then if this green distance is 25, this is also 25. So it's 160 across, but there's 2 segments of 25 we're going to cut out. Cutting means subtracting. So if you do 160 minus 25 minus 25, you'll get 110. So 110 inches, that is the length of this rectangle, length or width, whichever one you want to call it. So 110. And then area 3, which I need to switch to my green for, A3. This is 25, and this is 44. So 25 by 44. They all have a 25 in them, interestingly enough. Let me come off of annotate, get my calculator back. So for the first one, 83 times 25, we get 2,075. So 2,075. Then the 25 times the 110. That's going to be 2,750. And then the 25 times 44 is going to give us 1,100. And if you add up all of those, actually, you know what? I need to see if we can. I thought the view gave me all the different ones. No, that's not going to work. Okay, we're going to do this a little differently. I just want to be able to see those answers up there for y'all. everything, all the stuff. Let's pull out the good TI-83, because that'll keep everything. There we go. 83 times 25, 2075, as we said. Then the 25 times 110, and that's 2750. And then the 25 times 44. It was just going to take me even longer than pulling up that other calculator if I had to keep going back between annotate and calculate, annotate, calculate. And you can see that I made a typo here. So that should have been 25 times 44. That's what I mentioned earlier, that if I type too quick, if I click too quick, it doesn't show. So the 100 number was a mistake. We just have to add the 2075, so 2075 plus the 2750 plus the 1100. There was that, I double clicked and missed a 0, but I caught it, and we get 5925. So let's see if 5925 is our answer. 5925. Excellent. So this is a great concept of taking a big problem that doesn't make sense to approach it all at once and breaking it up into several smaller problems that we know how to handle. So that's a great example for that. Let's do another one. I need to clear my screen. There we go, back off of annotate. On the map to the right, 1 inch corresponds to 230 miles in the real world. How many miles actually separate towns A and B? So these assignments love towns A and B. You know, there's no Chicago, there's no Norfolk, there's no Richmond, no Virginia Beach. It's town A and B. So 1 inch corresponds to 230 miles. This is what we call a scale. This is something that we'll study pretty, I'd say extensively, but it's not that extensive, but we will study it in relation to the idea of proportions in chapter 3. We can use scales all over the world, but let's just get down to brass tacks. So for every 1 inch here, that's 230 miles. There's 3 inches, so that's 3 different sets of 230 miles. So one way you could do this is just say, all right, well, the first inch is 230 miles, plus the second inch is 230 miles, plus that third inch is 230 miles. And you get your answer of 690 miles. But what if this distance wasn't just 3 inches? What if it was 30 inches? Would you really want to type 230 plus 230 plus 230 plus 230 in total 30 times? I highly doubt it. So if you remember, the extension of addition is multiplication. So if 1 inch is 230 miles, maybe we can just multiply those and get a sensible answer. 230 times 3. Well, look at that, the same thing. So let's try it out. 690. Boom, we got it. All right. The area of Lake A is about 24 million square meters, and the area of Lake B is approximately 12 million square meters. Lake A is how many times as large as Lake B? Lake A is how many times as large as Lake B? So essentially what we're trying to do here is we want to take Lake A, its number, its area, times something, and then that would give us Lake B. So if you took Lake, I have these backwards, I'm sorry, that should be Lake B on the left. If you took Lake B and multiply it by a number to get Lake A, that's how you find out how many times Lake B is. Lake A is how many times as large as Lake B. That means to take some number times Lake B to find Lake A. So this would be pretty easy since these are clean numbers, but in the future they won't always be so clean. So Lake B is about 12 million. Lake A is 24 million. I think we can hopefully figure out a number to multiply 12 by to hit 24. If you took 12 times 2, you get 24. So this is what we're looking for. It's 2 times Lake B's area because you have to take 2, multiply it by Lake B to get Lake A. So if these were 12 and 36, then it would be 3 times as big. If it was 12 and 48, it would be 4 times as big. If it was 12 and 120, it would be 10 times as big. Now, you don't have to just magically pull that 2 or 3 or 5 or 10 or whatever else I said out of thin air. With practice, you figure out, oh, if I just divide these two things, I'll get the multiplier. But you got to divide them in the correct order. You got to do 24 divided by 12 in this instance. But who's to say it's not half as big? Maybe it is 12 divided by 24, depending on the wording. So you have to be careful. All right. So I don't know why that keeps doing that, but that's all right. So Lake A is 2 times bigger than 2 times larger, bigger, whatever, than Lake B, and we got it right. Fill in the blank with the most appropriate term or phrase, and this is where I'm going to start skipping around after 1 or 2 more, especially since we lost probably 20 minutes due to technological flubs. 2 numbers that are the same distance from 0 on the number line but are on opposite sides of 0 are called, well, the word is actually in there. 2 numbers that are the same distance from 0 on the number line but on opposite sides of 0. So if you have your number line here, and here's your 0, to the right we have 1, 2, and 3, to the left, -1, -2, -3. 2 numbers that are the same distance from 0 on the number line but are on opposite sides of 0. So for instance, this number 2, it's 2 because it's 2 units away from 0. And this number -2, it's -2 because it's also 2 units away from 0, but it's going left instead of right, so it's negative. So these are equidistant from what we call the origin, or 0. But one's positive, one's negative, they're on opposite sides. That literally gives you the name opposites. And absolute values and opposites kind of relate to each other in that way. And we'll talk about that another day. Mark the corresponding point for each of the following numbers on the number line. If it wasn't for the decimal, I'd skip this, but -1. You can just click, you can drag. So let's drag this to -1. Let's check it. That looked good. Then they want to locate 4.5, 4.5. So here's 4, here's 5. So that should be halfway between it. Looks good. And then 4. See, I can't just click. I have to go hover over the dot and drag it. There we go. Opposite, we already kind of talked about that. The opposite of 19 is -19. The opposite of -19 would be +19. They're 2 sides of a coin. Absolute value just makes the answer positive, whether the argument inside is negative or positive. If there's any math to do inside the absolute value, you have to do that first. So this right here looks like 11 kind of sandwiching another number. These are your absolute value bars. So because we have that, and there's nothing to do inside, it's just a single number, we say the absolute value of -2.7 is 2.7. Larger numbers are always further to the right on a number line. So I'm actually going to make up my own example because I don't think there's one that there is not. Good. So the bigger one between 5 and -2, I think, is very obviously 5. But let's say we had 0. We wanted to do it with -2 and -5. So this is the problem I'm going to focus on. Here's your 0, 1, 2, 3, 4, 5. Here's the 2. 1, 2, 3, 4, 5. Don't worry about the spacing being uneven, not the point of the problem. So larger numbers always fall to the right on a number line because a lot of people's instinct will be to say, well, 5 is bigger than 2, so -5 is bigger than -2. And that's not the case. -5 is to the left of -2. It's any number to the right is always bigger than any number to the left. So -2 is bigger than -5. That's the symbol for bigger or greater than. And again, it seems a little confusing at first because 2 is smaller than 5, but in terms of negatives, -2 is bigger than -5 because it lies further to the right. So I think that's a more important problem versus the numbers they gave me randomly. But again, they're randomly generated, so yours may look more like what I just did, or it could look like what was on the screen originally. Just depends. All right, we need to get into some of the Pemdas stuff. I'm not going to focus on signed arithmetic too much in here because you got calculators and you hopefully know how to use them. If not, become acquainted with them. I will very, very, very quickly say the rules. Can you hear me? For adding and subtracting, if they are the same sign, add the numbers and keep the sign. They are different signs. Subtract the numbers, larger minus smaller, in absolute. So remember I just said that a number is bigger if it lies to the right on the number line? I'm saying even with the signs that you see, just think of them in absolute. So if you saw a -7 and a 5, then you'd want to subtract 7 minus 5. You just ignore the original signs that you see because you're going to keep the sign, the bigger number. And I say bigger because, again, I'm talking in absolutes. Multiplying and dividing. These rules are a lot clearer and simpler if they are the same sign. Let me just be more specific. If the two numbers are the same sign, the answer is positive. Two numbers, because this rule doesn't apply for 3 or 4 or 5, it's just 2, are opposite signs, the answer is negative. I have some little abbreviations for these that I've always liked that I actually made up on my own many years ago. And they are SAK and DSL for the addition subtraction rules. And if you don't like abbreviations, if you don't like memorizing, you don't have to, as long as you can get the job done one way or another. So this is if they are the same sign, you add the numbers and keep the sign, SAK. If they are different signs, you subtract the numbers and keep the sign of the bigger or larger number. So there's your L. I should have said larger instead of bigger. SAK, DSL, same, add, keep, different, subtract, larger. I don't know, it always worked pretty well for me. I've had some students it works well with. Others don't like abbreviations, so they don't use it. That's up to them. For multiplying and dividing, if the two signs are the same sign, the answer is positive. If they're opposite signs, notice I choose my words specifically. Instead of saying different, I say opposite, and that's just for my abbreviation. The answer is negative. Together, these form SPON, spawn, like spontaneous, or spoon with only one O. So there's 2 separate ones for adding and subtracting. There's one combined one for multiplying and dividing. And again, this is something that you're supposed to already know coming into this class. You are supposed to know the prereq material, and this is prereq material. I'm being nice and kind of giving 5 minutes towards it. I won't bring this up again. And again, is it the end of the world? No, because you got calculators, so they can certainly handle it for you. They can go -15 plus -49. But you got to know how to handle your calculator. Because plugging in of negatives, if you've got like a TI-30 or some random Casio, notice I typed the negative first. You might have to type 15 and then the negative. So your input might look like this, and it's going to look really weird on my screen because it doesn't work for mine. But again, you have to learn your calculator, and to learn your calculator, you got to know at least how to do a couple of the problems, right? To make sure that your answer is right, to make sure it makes sense. So these were the same sign, negative, negative. So add the numbers, 15 plus 49 is 64. And then I keep the sign of the original, -64. It's correct. I'm going to skip the checking of it. -12 plus 4. So these would be different signs. So you'll subtract 12 minus 4. Again, ignoring any signs when you're doing your subtracting and keeping a bigger. So 12 minus 4 is 8. But then you keep the sign of the larger in absolutes 12. So we keep the negative. So -8 should be our answer here. Without doing the calculator, let's see if that's right. It is. So again, we did 12 minus 4 because these were different signs, so we subtract. And then the 12 is larger, so we keep its sign, which is negative. If I did it this way, -12 plus 4, I get the same thing. I can actually swap these as long as I swap the signs too. I can do +4 minus 12 or plus -12 if you want to do it that way. Because adding a negative is the same as subtracting a positive. That's something else that you're supposed to know. Either way, I get -8. But there are plenty of ways to have done this wrong. But there's plenty of ways to do it right. Decimals, if you're doing this by hand, line up the decimals when you're adding and subtracting. I'm going to guess most of you are going to use a calculator, and because it's QR, I'm not going to fight you over it. If this was pre-calc, we'd have arguments. More sums, so I feel like you can do this on your own. Ugly decimals, we'll do this when it's a little uglier. Let's just make sure we can type things right. 8.362, I'm being careful. Adding a negative is the same thing as subtracting, so I could key in plus -9.27, but I like to just go minus 9.27. And then plus another negative, or I could just subtract 4.65. Let's see, -5.58. They don't say to round anywhere in the instructions, so I should probably type in -5.558. I may have missed saying a 5 earlier, but it is there, and we got it right. Pay attention to instructions. I can't tell you how many people get things wrong on homework first because they're not paying attention. Oh, round to the nearest 10th, something like that. More arithmetic, more arithmetic. Again, you're more than welcome to do these on your own. Please do them on your own. Make sure you practice this. If you're super rusty with these skills, it's a skill you should have, so try and do it without the calculator, then use the calculator to confirm. Remember, these won't make or break your grade. There is no grade in MDE 54 besides pass or fail. -12 divided by -3 times -3. This is where we start getting into Pemdas, order of operations. So let's label it. Order of operations. MDAS. I'm not doing the M and the D on separate lines. I'm doing them together because there's only 1, 2, 3, 4 steps for Pemdas. Please excuse my dear Aunt Sally. Also stands for parentheses, exponents, multiplication, division, addition, subtraction. This is also supposed to be in your belt, our MDE 10, I believe they now call it, which was Math 3 in the past, or MTE 1 through 3. It's had so many names. Because reasons. But there's not 6 steps to these 6 letters, it's only 4. So parentheses, exponents, they're their own steps. And when we have a step, you do them in the order from left to right as seen. So MD, multiplication and division, that means as you're looking from left to right, if you see a division first, then a multiplication, you do them in that order. So for steps 3 and 4, you are looking for either as you scan right and doing them in that order. So if I had something like, I won't complete this problem since we have some over on the other screen, 4 times 8 divided by, that's not an 8, that's an X, divided by 2 divided by 4 times 3 times 2. So the slash is a division, the star is a times in keyboard notation. You would do them in that order from left to right. You would do the multiplication first, then you would do the division second, then you would do this division third, then you would do this multiplication fourth, then you would do this multiplication fifth. I would not do the 3 multiplications and then go do the 2 divisions. That answer would be wrong, 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 wrong. So 4 times 8, what's that? 32, divided by 2 is 16, divided by 4 is 4, 4 times 3 is 12, 12 times 2 is 24. That is most likely a very different answer than if you did all the multiplications, then all the divisions. There's, you know, once in a blue moon, there's a coincidence, but it's just that, it's just a coincidence. So after you do all your multiplications and divisions, then you scan for your additions and subtractions, and you do them in the order seen from left to right. Again, I like to use social media as kind of a scapegoat with this type of problem. Back before I canceled myself on social media, and I mean, I just got rid of it. Don't use it anymore, whatever. You see people arguing over these basic types of PEMDAS problems, and you get into really, really good fights with people that just absolutely know they're correct, and that it's 6 steps, and you do all the multiplications, then you do all the divisions, but they're wrong. That's the problem with the internet. Everybody can be right. All they got to do is just keep typing. But we are not on the internet for that reason. We're on the internet to learn and get it right. We're on the internet, though, that's for sure. As proven earlier. All right. So -12 divided by -3 divided by -3. So even though there's a multiplication, we don't do that first. We don't say -3 times -3 is +9 and then divide. In fact, we'll get a fraction as an answer, which that's okay, but that's not the answer this time. We're supposed to do the division. -12 divided by -3 would be +4. A negative divided by negative is a positive. There's rules you can see just above here. So the first pair of numbers gives us a +4. So then we got 4 times -3. These are opposites, so the result is negative and should be -12. And -12 is the correct answer. If you don't trust me, there we go. I need to clear my screen. Annotate. Clear. There we go. All right, here's a much beefier problem. I'm getting really annoyed with the annotate, so I'm just gonna have a Word file open to the side, and let's do the work there. That'll make our lives a lot easier. Can I do this? Boom, there we go. All right, -7 times 7 plus 3 times 7 over, all over, -5 minus -3. First of all, minus a negative makes a plus. That's the first correction you should have up here. First, not correction, but simplification. So that should be -7 times 7 plus 3 times 7 all over -5 plus 3. Now this big division bar, this thing right here, this big fraction bar, excuse me, counts as a division, but it also kind of says that there's an implicit parentheses or bracket around all this stuff. So in other words, you need to simplify the top and bottom as much as possible before you start crossing this division bar. So we need to simplify the top and bottom before we start trying to do the final fraction. So we have a multiplication, addition, and a multiplication. We're going to do them in that order, or sorry, in the order from left to right. First of all, multiplications, then we'll do the addition last. So -7 times 7 is -49, then plus 3 times 7 is 21. See, I did the multiplications before the addition because of the PEMDAS, because of 4 steps. All over -5 plus 3. In the top, that's an addition. These are opposites in sign. 49 minus 21 is going to be 28, but we keep the larger number sign, so -28. -5 plus 3. 5 minus 3 is 2, but the larger is negative, so -2. Only one more step, and it's division. But Mr. Beckner, you said division should come before additions and subtractions. Yes, if there's no parentheses, and I said that these fractions with all these extra operations, this counts as what we call an implicit parentheses. Brackets and parentheses, same thing. So that's why we're doing a division last. That's what parentheses do. They make it so we can change the order if necessary. -28 divided by -2, well, 28 divided by 2 is 14. Opposites cancel in division and multiplication, so that answer should be +14. Let's try it out. And there we go. Square roots. These are what we call an implicit problem because it's like having the answer and wondering what the question is. But you can't ask the question until the inside is simplified as much as possible. So we have an addition and a subtraction. It doesn't matter the order they're in. If I saw the subtraction, then the addition, I do them in that order from left to right because it's one combined step. 6 plus 3 is 9. 9 minus 8 is 1. So what we have is the square root of 1. And what we're asking for is what number times itself is equal to 1. So this has to be the same thing. And I think it's hopefully obvious at our level that 1 times 1 is 1. So 1 should be the answer. So like the square root of 4 would be 2 because 2 times 2 is 4. The square root of 100 would be 10 because 10 times 10 is 100. And there aren't whole square roots for every number in the world. If you try and take the square root of 5, what did I do wrong? 6 plus 3 is 9. 9 minus 8 is 1. The square root of 1 is 1. Do they just want the square root in here still? That seems weird. Okay, so I don't like that. I didn't know that's how they wanted the answer done. I would never want to see that anywhere else in our course. Yes, doing the additions and subtractions gives us 1. But the value of this expression is supposed to be 1 because you should know how to take square roots at this level. And again, things like the square root of 4, that was weird, should be 2. The square root of 9 should be 3. The square root of, I'm skip around a little, 25 would be 5. The square root of 121 would be 11. You should know up to about 13 as an answer. So the square root of 169 is 13. Do you have to know them? No. You can use your calculator if you have to, but again, this is a skill you should have. So here's how I get to my square root. Square root of 121. I don't even have to close the parentheses if I don't want to in this format, and it's 11. All right, about 2 more minutes. Here we go. I do like this one. A student has a credit card balance of negative $3,884. It would be my ideal goal to get all of you to have the mindset to get this to 0 as soon as you possibly can, but we'll save that for the end of the semester. If he sends a check to the credit card company for $2,053, then uses his card to purchase a camera for $614 and some film for $10, what's the new balance? So we're adding and subtracting things to this. So because this is a negative amount, this is debt. So we currently owe $3,884. If we send a check in, we're going to be adding to that pile of money. We're giving money to the bank. So our 3,000 and some change debt should decrease in size. Now, let's just try and do this wrong real quick. So this is wrong. Let's say you think you're supposed to subtract the 2053. Now we owe the credit card company $6,000 almost. Does that make sense? No, we owed almost 4. Now we should probably only owe about 2. So that says I did something wrong. I paid attention. I asked if the answer made sense. So let's try again. Plus, and that's again because our debt, what we owe, we're considering a negative number. The credit card company can actually flip that. A lot of accounting and the math feels backwards, but we're not accounting, so it doesn't matter. So that was our payment. Now we owe less, so this makes sense. We owe significantly less. But then we got to go and buy a camera and some film, maybe for our starter business, so we can get rid of this credit card debt. So this is more debt, so we're going to subtract those. So with my calculator, I can actually just hit minus, and it takes the previous answer, and we'll continue. So minus 614 for the camera, and then minus $10 for the film, because it's not digital. Some people still use non-digital cameras, and instead of film, you could say memory card. That would make it more modern. So now we have a balance of negative 2455. Check, boom, we got it. So at least we don't owe as much as we originally did. One last problem just for fun. What digit is in the hundreds place? So for whole numbers, we start with the ones, then the tens, then the hundreds, then the thousands, 10,000s, etc. So the 0 would be in the hundreds place. One thing I want to mention, because this problem didn't get into that, when we're talking about after a decimal, so like if I had 32.571, the 2 is the what we call the ones position, the 3 is the tens. Anything to the right of a decimal, we add a THS to the end, but there's no once. The 5 is in the tenths. The 7 would be the hundredths. The 1 at the end would be in the thousandths. et cetera, et cetera, et cetera. There were more numbers and more places. So just understand there are no oneths. The first number after the decimal is called tenths because it takes 10 of these to make a single one. That's the idea there. That's why there's no oneths. All right, so it's been a little bit of a chaotic day. I do apologize for the technological issues. That audio thing earlier, I'm willing to bet my money on that was probably my internet dying at the time, going in and out. Yay, Cox Cable, right? One of these days I'll get FiOS, especially in the land of pine trees. All right, so I hope this was helpful. Again, I apologize. I can't apologize enough, but I hope you're at least able to laugh a little at the situation like me. Because again, what else can we do? Thank you for hanging out. That was really awesome of y'all. I was expecting most of y'all to be gone, or at least half of y'all, since there was a good time gap. It wasn't just 5 minutes. So have a good one. Email me with any questions. Please start trying to work on this. Don't forget all the Math 154 important stuff like that quiz. Get that Excel file to me in the next couple of days. Remember, you're submitting that in Canvas, all that good stuff. And I'll get up on YouTube what I can salvage from what we had out of this. I'll see if I can combine those last 2 segments. I don't know. I think I can do that. I just got to Google. All right. Take care, everyone. Thank you for your patience.